friends, welcome to this electronics lecture series. And we have been studying gate triggering circuit. In previous video lecture, we have studied resistance firing circuit where this is the AC source, this is the load, this is the SCR, and by triggering this SCR at appropriate instant, it can be turned on, and when SCR is on, current flows and power is delivered to the load. So depending upon how long SCR conducts, the average power from this source to the load can be controlled. But in that circuit, we have seen that the firing angle can be changed by this variable resistor RV. By changing this resistance, that means if this resistance is kept small, SCR is fired in every positive half cycle earlier, and therefore average value of the current flowing through the load will be more and more power delivered. Then we have also seen that when this resistance is increased, SCR fires late in every positive half cycle, and therefore the average power delivered to the load is less. But there is a major drawback of this circuit, and which we have discussed actually, that this firing angle by increasing this resistance can be delayed up to 90 degree only, because by increasing this resistance, and if up to 90 degree, if we are not getting IG minimum, SCR फायर करने के लिए मिनिमम गेट करंट चाहिए, वो नहीं मिला तो उसके बाद मिलने के चांसेस नहीं, एंड देयरफॉर SCR cannot be triggered. So this is a half wave rectifier, and we have control. We can change this firing angle from 0 degree to 90 degree only. That was the limitation, and this limitation is removed in the next circuit, and that is resistance firing circuit. Remember that the firing circuit or triggering circuit is the same. Okay, now look here, what is the change here? See, this is the AC source, load as it is, only one SCR, and the connection is right. Only thing is that we have removed this R minimum, this resistance, and we have introduced this capacitor and this diode D2, and see that we get a very interesting property here. So in this circuit, resistance R and capacitance C are used to get large variation in firing angle. And कैसे मिलता है ये? It is obtained by changing phase and amplitude of gate voltage current. गेट वोल्टेज और गेट करंट, तो यहाँ जो गेट करंट मिलने वाला है उसका एम्पलीट्यूड और फेज बोले तो either earlier or little late, that can be decided. And again, how to vary this? Just by varying this RV, variable resistor in the circuit, we are able to here to vary the firing angle right from the 0 to 180. You can understand this. 0 to 180 degree means a complete half cycle, and already this is a half wave rectifier. There is no question of current in negative half cycles. So only thing is that we have to control in positive half cycle, and we have full control on that is full half cycle. Okay, let us see how we get this. Once again, see that I have copied this circuit here. This is the AC source, this is the load, this is the SCR, this is the diode D1 which prevents the gate current in the reverse half cycle, and this diode D2 is reverse connected. See how it works. Suppose that initially there is a negative half cycle. That means you have to imagine from negative half cycle. So during negative half cycle, ये ऊपर का जो टर्मिनल है ये नेगेटिव रहेगा और ये नीचे का टर्मिनल है पॉजिटिव रहेगा. And look at that, up through load this wire is like this, then there is a variable resistor, and then this is a negative terminal, positive terminal. See that. So this diode D2 gets forward bias during negative half cycle of the supply, and because of that instantly it charges this capacitor, and you know that in AC capacitor gets charged to मैक्सिमम वैल्यू. इट मीन दैट ये AC का जो मैक्सिमम नेगेटिव एम्पलीट्यूड है उसे हम कहेंगे E मैक्स, कैपिटल E, कैपिटल मीन्स एम्पलीट्यूड मैक्सिमम विथ अपर टर्मिनल नेगेटिव. During negative half cycle, capacitor is charged to negative peak value of the supply voltage. This is very important point. Okay, that means upper plate voltage is very large negative. Okay, and so long it is negative, the SCR is off. So during negative half cycle, SCR is off. Now consider next, say positive half cycle appears. As positive half cycle begins, कैपेसिटर नाउ मतलब ये ऊपर का टर्मिनल पॉजिटिव होगा विथ रिस्पेक्ट टू निगेटिव एंड सी दैट दिस पॉजिटिव टर्मिनल एस इज ऑफ दिस विल चार्ज दिस थ्रू आरवी. ये आरवी के द्वारा एक कैपेसिटर को चार्जिंग करंट मिलेगा. नाउ D2 इज रिवर्स बायस बिकॉज पॉजिटिव हाफ साइकिल हैज बिगन और ये चार्जिंग करंट विल चार्ज दिस कैपेसिटर. यू सी upper terminal voltage, capacitor's upper terminal voltage begins from minus E max and therefore it will take more time to get positive and to get some triggerable voltage, right? So as positive half cycle begins, capacitor C begins to charge from minus E max to positive voltage through RV, and when this voltage reaches to Vg minimum plus Vd, this is the diode के अक्रॉस कुछ वोल्टेज रहेगा और यहाँ गेट को कितना लगता है Vg मिनिमम. Vg मिनिमम क्या है? मिनिमम गेट वोल्टेज रिक्वायर्ड टू ट्रिगर दिस SCR. तो वो VGT प्लस दिस ये डायोड का वोल्टेज जब यहाँ आएगा तो ये SCR ट्रिगर होगा और वो कब आएगा दैट इज डिसाइडेड बाय दिस चार्जिंग रेजिस्टर एट द वैल्यू ऑफ द कैपेसिटर, राइट? And there is a function that D1 prevents the damage to gate cathode junction of SCR during negative half cycle. So let us discuss these things once again with the help of waveform. See that this is the source, load, SCR, the same circuit here, but I have shown here the waveform. See, upper waveform is for the supply voltage AC. See, this is negative half cycle, from this positive half cycle, negative half cycle, positive half cycle. This is one cycle and the period is capital T. Okay, now we have discussed from first negative half cycle. So during this negative half cycle, this capacitor upper plate charges to minus E max. This is the voltage. Okay, and as this voltage reaches to zero, कौन सा ये सप्लाई वोल्टेज AC का है, ये माइनस मैक्सिमम होके जीरो हो रहा है, राइट? हो गया जीरो. आफ्टर जीरो इट बिकम्स पॉजिटिव. तो ये अपर टर्मिनल पॉजिटिव होने के बाद ये रिवर्स बायस हो जाता है. डायोड D2 का काम क्या है? सिर्फ कैपेसिटर को रिवर्स चार्ज करना. और जब पॉजिटिव हाफ साइकिल आती है तो इट वर्क्स एज अ ओपन सर्किट. नाउ करंट फ्लोज थ्रू द वेरिएबल रेजिस्टर that charges this capacitor, and see that this dotted line which I have drawn here, this is the voltage, capacitor voltage. So voltage across capacitor increases like this. Why it increases? Because the upper terminal has become, upper wire has, this upper line has become positive, and through RV charging current will flow, and at voltage at this dot increases. And see that how it increases. From negative maximum it increases, and it becomes zero here, and then it becomes positive, and then it becomes VGT, where VGT is the gate voltage triggering voltage. मतलब इतना VGT आने के बाद SCR ऑन होने वाला है. तो कैपेसिटर हैज टेकन, सी हाउ मच टाइम फ्रॉम दिस to this to reach VGT. Why it is so? Because of large resistance and this capacitor. And once that voltage across capacitor reaches to VGT, SCR fires, and therefore see that waveform for the load voltage up to that instant. ये टाइम एक्सिस है, या तो एंगल देख सकते हैं आप. जब तक ये VGT नहीं बनता, वो कैपेसिटर का अक्रॉस वोल्टेज VGT को रीच नहीं होता, तब तक SCR ऑफ है. एंड सी द फायरिंग एंगल अल्फा is from 0 to very large. It is a well extended beyond 90 डिग्री. पहले सर्किट में क्या था, ये अल्फा 90 तक ही बढ़ा सकते थे. यहाँ ये VGT कब आएगा कौन डिसाइड करेगा? ये वैल्यू ऑफ रेजिस्टेंस, एंड यू कैन वेरी दैट. सो बाय वेरिंग RV कन्वीनियंटली यू कैन फायर इट अर्लियर और लिटिल लेट. अगर इसको छोटा करोगे आप तो बहुत पहले शुरू में फायर होगा, और बड़ा होगे तो लेट फायर होगा. और लेट फायर होगा तो ये देखो डार्क लाइन इंडिकेट्स दैट वोल्टेज अक्रॉस लोड, मतलब average voltage available across load here can be controlled by the firing. पहले फायर करोगे तो ज़्यादा समय तक वोल्टेज रहेगा, और लेट फायर करोगे तो लोड के अक्रॉस कम समय तक वोल्टेज रहेगा। ज़्यादा समय मतलब मोर एवरेज पावर डिलीवर टू द लोड, और कम समय मतलब कम पावर डिलीवर होगा। सो दिस इज हाउ power delivered to those load can be controlled. What is actually this RC network? It changes the phase. यहाँ फेज चेंज किया, वेवफॉर्म का शिफ्टिंग हो गया, एंड दैट्स व्हाई वी कॉल इट एज अ चेंजिंग द एम्पलीट्यूड एंड द phase of gate voltage with respect to line voltage, and that's why we get this wonderful effect. And this is the empirical formula. What should be the value of this variable resistor and this capacitor? So it should be greater than or equal to 1.3 times of T by 2, where capital T is this much. You see, for power supply, AC voltage, source voltage, this much is capital T, one cycle, complete cycle. आधा कितना आएगा? T by 2. तो ये T by 2 का आधा है, आधे के कितना टाइम होना? 1.3 टाइम्स ऑफ T by 2. इससे ज़्यादा अगर RVC है तो you can fire this SCR anywhere from 0 to 180. And see the super control, that means 0 power to maximum power you have. Of course, this is a half-wave rectifier. These things happens only for positive up cycle. During negative up cycle, our SCR remains reverse bias, so there is no question of the current. And you can easily understand that the firing angle can be controlled over 0 to 180 degrees. So this is a very wonderful circuit. Just addition of one capacitor and diode, you can control the power delivered to the load over 0 to 180. So it is time to stop here. See you next time with next circuit. Bye.